Hello and welcome back to A Boring Revolution, your number one news source, everything in regards to the Boring Company. My name is Will, hitting you today with another predictions episode. This is my all-time favourite predictions episode. I've been thinking about this for a long time. It doesn't really play into my area of expertise, but I think it's absolutely critical to this project. And what basically people have been saying to me on Reddit, on Discord, on various other talk forums is this kind of system is viable. So I'm going to talk about it today. I think this could be a real game changer for the Boring Company and Elon Musk. So let's get talking. So I presume you're all wondering why I'm so excited today. This is interesting. If you've not watched one of my predictions episodes before, basically what happens is I'm looking into predictions that are going to occur in the next sort of 18 months towards the end of 2020. So I make a prediction, then we go and look back at it in 12 months and decide, was this a good prediction? Was it based on, solid grounds, or was it basically just pie in the sky thinking and amounted to nothing? Hopefully it happens loaded AEV from 0 to 15 miles per hour in under 4 seconds. So let's say that again. The Boring Company and Tesla will develop a cutting-edge elevator system capable of moving a fully loaded AEV from 0 to 15 miles per hour in under 4 seconds. What do you think? I think this has to happen to make this system work efficiently, as in putting cars into the system and taking cars out of the system. It needs to be done very, very quickly in a timely manner. And I think the best way to do that is to develop an elevator system that is fit for purpose. Because the current elevators we're using are based on the old kind of elevator designs. I don't think they're fit for purpose. So I think we need something new, something that has never been done before, something that sort of leans on the kind of expertise and experience that the Boring Company and Tesla has in abundance. So why do we need this? Is this really required? Why can't we just use old technology and worry about other things like the TBM? Well, elevators are a potential choke point and current technology isn't fit for purpose. The elevators we've seen for moving cars tend to operate around maybe 3, maybe 4, maybe slightly more than that, 3 to 4 miles per hour. It's not really going to be good enough for what we need. Current Rack and Pinion elevators are heavily based on original designs and systems from the 1960s and 70s. There has been absolutely, or next to zero, innovation. I'm sure they've invented a few little bits and bobs to make it safer, but nothing to make it quicker and to lift more and to be more reliable. It's very much stayed the same. There's been no development, a bit like TBMs. So we need to look at Rack and Pinion elevators again and start from a blank canvas, build something that's never been done before, that's going to be fit for purpose for the Boring Company, for moving vehicles in particular. So Tesla possesses some of the best electrical and mechanical engineers on the planet. If there's anyone that can do it, it's going to be Tesla and the Boring Company. Tesla's electric motors, batteries and software are some of the most advanced in the world at present, and probably will be for the next 5 to 10 years. So they've got the people that can build something that's a world first and does the job how we want it to do. Number 5, electrical automobiles have some common components, I stress some, shared with modern elevators. So potentially some of these parts could come off the shelf, or they could come off the shelf and then be modified to work with this system. A very promising vertical integration opportunity for Tesla and the Boring Company. If they can make their own elevators, then they can supply them to people all over the world for their loop systems. If they're the only people that do the production, manufacture and maintenance of these systems, they're going to have a huge advantage. It's a potential, multi-million-dollar business in its own right. Rack and pinion elevators can be driven by multiple motors. Point number 7 is the most critical point of all. I would not be looking at rack and pinion elevators unless that was possible. The fact that we can almost put an unlimited number of motors into the platform, all you've got to do is make the platform bigger, means that we can up the power, up the torque, up the lifting capability of these elevators very easily, and they all operate at the same speed at the same time simultaneously. That means it's going to be very smooth, very quick, and hopefully very reliable. Because you've obviously got, if one motor fails, you've got 7 others to back you up essentially. So what is rack and pinion? Now, my personal experience with rack and pinion elevators are hoists. I've worked on jobs where I've had multiple hoists. You tend to pick up the phone, call up a hire company, tell them that you need a hoist for moving X amount of kilograms. They turn up and then they assemble this rack and pinion elevator. It tends to be quite clunky. It is installed very quickly with the right team, but it's fairly slow, and it can hold very heavy weights. That's the key sort of advantage of rack and pinion, is that I've seen them move 3, 4, sometimes even 5 tons of 5,000 kilograms of gear at the same time, multiple times, 8, 9 hours a day. So all in all, rack and pinion elevators have been very, very good to me. So I think they can be modified for this particular system. Here's what they look like in the kind of basic form. The pinion is the gear that's spinning or is driven by the motor, and then you have a rack which is fixed to either a wall or maybe as part of some kind of scaffolding frame. A rack and pinion is a type of linear actuator that compromises a circular gear called a pinion engaging a linear gear rack, which operate to translate rotational motion into linear motion. In theory, any elevator can be powered by multiple electric motors that rotate each individual pinion. So each individual gear has its own motor. You can determine how powerful that motor is. Imagine 8 pinions driven by 8 motors, and that's what we're going to talk about today, or 10 or 16. There's no sort of limit to this. You could have a double platform. You could have a platform that's 34 foot long, 10 foot wide, and you could have that driven by 20, 40, maybe even 60 motors if you really wanted to. I'm not sure it'd be viable doing it with 60 motors, but you can see what I'm trying to get at here. There is really amazing possibilities with this potential system. So, by using multiple racks on the shaft walls, that also ensures the process of lifting AEVs is as efficient as possible and dramatically increases the acceleration of the elevator from 0 to 15 miles per hour. That's the most important thing. The top speed is not important. It doesn't bother me if we can use a different type of elevator, like a traction elevator, and it does 28 miles per hour, because we've got a very short shaft. So we need to concentrate on getting from 0 to 15 miles per hour as fast and as efficiently as possible. And rack and pinion is basically the only viable way of doing that. So, I've been busy on the old sketch pad and I've drawn this. This is basically the floor or the actual rack and pinion elevator. This is what is going to contain all our components to drive the elevator. It's all contained in one homogeneous unit, which is absolutely perfect because we can build it off site and then just drop it in. So it's got, as you can see, these things here. These are steel columns, as it were, mounted to the shaft walls. Shaft walls are here on the dotted line. This here area here that's shaded, that is where the teeth of the gear meet the actual rack. So you've got the pinion meeting the rack that is basically mounted on the wall, is fixed at all times. I have put in a battery unit inside this. I think that's probably the best way of doing it, although it doesn't necessarily need to be some huge 100 kilowatt hour battery. You might even be better just using recycled batteries from Teslas that have maybe been written off, potentially. But it doesn't need to be 100 kilowatt hour. It could quite easily be around the 50 to 60 kilowatt hour mark, maybe even less than that, because you're going to be charging it. Sorry about that, guys. Regular, you're going to be charging it sort of every 10 minutes. Quick 2-minute charge, then use it. Quick 2-minute charge, then use it, and then obviously the battery pack is going to be well topped up all the time. So, what else have I put on here? So we've got our central process unit there, top, and at the bottom we've got our battery management system. This is the actual side view, or the cross section of the platform in the Rack and Pinion elevator. As you can see, we have a charging dock at the rear of this elevator. There will be almost like a lift pit, which is an area below the floor of the actual shaft where the actual elevator will sit. So it will be flush with the floor inside the tunnel. Inside there we'll have a charging point. Maybe we even use our snake charger. That snake charger will come up, maybe say 4 or 5 inches, into our charging dock, and then it'll charge the elevator platform relatively quickly, and then it can be used pretty much 24 hours a day without worrying about the battery running out. Shaft walls are the dotted line again. So the area in green is where we could potentially put our battery. I mean, this platform doesn't need to be super thick. It could be as little as 11 inches deep. It probably end up being more because you want it to be sturdy. You don't want any deflection in that platform when you're loading it up with heavy vehicles. So it's probably be more around 12 to 14 inches deep. But at the sides, you'll have your motors, which drive the pinions. What I'd also suggest doing is having pinions that are driven from the motors. Then you'd also have a set of pinions that are not driven by anything. They're essentially free moving. And what they do is they'll stabilize the platform, also provide additional safety in the event of an earthquake. In the event of a pinion snapping, it obviously ensures that that platform is adequately balanced. We don't have this sort of like tilting if there was a failure. So that's kind of another safety mechanism. So we put our pinions in sets of 3. So for every 1 pinion that's driven via a motor, you'd have another 2 pinions that are set below it that are just mounted on that rack. So why is this not common? Why are we not seeing rack and pinion elevators that are driven via 8, 10, 16 motors? Why not? Because clearly it'll work. Well, it's very, very clear. And basically the elevator market is dominated by one system, certainly the passenger elevator market. The actual industrial elevator market is fairly small. And if you're working in a bread factory, it doesn't really make a difference if that elevator goes 4 miles per hour or 7 miles per hour. You're still going to get that bread to the 3rd floor from the basement. So it doesn't. No one has ever needed to do this. That's the main reason. And traction elevators are a good system for passengers. They've worked very, very well for the last 120 years. Why change them? They are very fast. It takes them a long time to get up to the speed, but they can go up to 35, 40 miles per hour if you really wanted them to. So we've got traction elevators dominate the space. Around 90% of elevators are traction elevators. They're fast. They're very power efficient. A lot more power efficient than a rack and pinion elevator. Probably maybe 200% more energy efficient than a rack and pinion elevator. And also they're cost effective because they're obviously mass produced and people know how to build them and to maintain them. So it's there's a lot of advantages to a traction elevator. No one has ever required an engineer to make a 400 kilogram vehicle travel vertically up a 50-foot shaft at 50 miles per hour. It's just never ever been, no one's ever asked an engineer to do such a thing. And if someone has, they would have just been laughed at, because it's like, well, why do you want a vehicle to go up a shaft? That doesn't really seem like something we need to do. But the Boring Company needs that to happen. Need to get cars in and out of the tunnels fast, efficiently and safely. And I think this is the perfect system for it. So existing industrial elevators work fine, they're reliable and affordable. So we're not going to be using industrial elevators for this system. We want something brand new. So I've been asking myself this for the last 2 months. Is this feasible for the Boring Company? According to everyone that I've spoken to, absolutely 100%. The expertise required to design and manufacture such an elevator is readily available at Tesla and SpaceX. And the Boring Company obviously has got some people as well. It doesn't require some kind of technological breakthrough. Simply up the power output to 400%. Increase the power, increase the torque, increase the lifting capacity, increase the top speed. That's basically how they're going to do it. With most industrial hoists operating at 330 foot per minute, which isn't too bad. I mean, I had a hoist on a job I worked at in Leeds, and that was going up 12 stories in under a minute. That's fine for that particular use, but that's only using 1 or 2 motors. What happens when you use 8 motors, which are really geared towards doing this quickly? We're not far away from the required 1,200 foot per minute, which would be 20 foot per second. If you've got a shaft that is, say, around 40 to 50 foot deep, that kind of, with your acceleration built into that kind of around the 3 to 4 second mark that we're after. Tesla already manufactures powerful electric motors for its Model 3 and semi-truck. Maybe, I'm not 100% on this one, but maybe they could be used here, or a modified version could be used in these elevators. Construction hoists regularly move loads in excess of 5,000 kilograms, so heavy loads are no issue. I mean, I think at worst case scenario, our vehicles will be around 4,000 kilograms, so it's not a problem. It's been done in the past with less motors and less power. You know, if we're talking about a really high voltage, high amperage rack and pinion elevator, the kind of power that you could pull out of that thing would be absolutely insane. The acceleration would be mind-boggling. So, final thoughts. As I've told you, I've been very excited about this episode. I am very bullish on this idea. This has got, somehow we've got to get this to Elon Musk's desk. We've got to tell him about this idea, ask him why he's not doing it, why he's not thinking about it. Maybe he is. Maybe he's already building this in some kind of warehouse somewhere. We just don't know about it yet. This is buildable and very viable. I can assure you of that. A high-speed boring core elevator would dramatically improve the loop's vehicle capacity. If you could, put 5, 6, 7 elevators, if you could put 5, 6, 7 vehicles through an elevator per minute, which would be very possible, that is an incredible increase in the potential capacity of this system, because you can just be stacking those vehicles, boom, 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 straight into the tunnel, zoom, straight through, back the other side, then boom, right to the surface. No waiting whatsoever. That would be absolutely perfect. And all you do is add more elevators if you need them. So, you're getting a lot of bang for your buck with each elevator that you put in. Elevators could be prefabricated and then installed on site in under a week. Probably less than that. I think I'm being quite pessimistic with 1 week. If you could build the actual platform itself, as a one unit, and then just ship it to the site, all you got to do is install your rack on the wall there, install your power supply line, and then there you go. You're done. You've just got to finish the actual shaft itself. Would be another selling point for this system as a ride in itself. When that picks you up and accelerates you up the actual shaft, that would feel, you'd feel it in your stomach. It would be fun, really fun. Hopefully not too much fun for some people. So, thank you guys. Thank you for watching. As always, please like and subscribe. Join me on Discord if you've not already done so. I'm on Twitter and Instagram. I'm taking suggestions for new videos, come on Discord, tell me what you want to know about the Boring Company and give me some ideas about what videos I could do in the future. I'd appreciate some feedback on Prediction 12. Drop it in the comments below on YouTube or tell me on Discord or even Twitter. Just let me know, guys, and then I can improve for next time. Also, a big thank you to my Patreons. Some very, very great people helping me out, supporting this channel. They are Ashley Hill. Thank you, mate. We've got Mike McLean. Thank you, pal. We have David Mackay. Thank you, sir. And Christopher Kinsey. Thank you very, very much. Brilliant. Brilliant. So, thanks for watching, guys. Hopefully see you soon. Remember, stay tuned and subscribe to the channel. Thank you and goodbye. See you later.